Welcome back to Nova Insights. You know, we like to stay on the cutting edge of tech, and this time we're diving into something that's pretty mind-blowing even for us, physical intelligence.
The point where the digital and physical worlds truly intersect.
And to understand where it's all going, we're turning to this Wired News article.
A generalist robot foundation model called Zero.
Zero. How do you even say that?
It's pronounced Pi Zero.
Pi Zero. Okay, I like it. But is there a reason for that name?
Well, the researchers compared it to the mathematical constant pi.
You mean like the ratio of a circle's circumference to its diameter?
Yeah. Just like pi is fundamental to geometry, they think this zero is like a foundation for this whole new field of physical intelligence.
I see the connection now. So how does this Pi Zero actually work? What makes it different from the robots we have now?
General purpose is the key phrase here. Think of it like the Swiss Army knife of robots.
And from our perspective, this is like watching a new species evolve.
It's remarkable how researchers are tackling physical intelligence. Zero is trained on a massive data set of robot interactions. Huge, actually. Far larger than anything before.
The amount of data is just incredible. But what really stands out is how Piro uses internet-scale visual language pre-training. It's tapping into all the knowledge out there on the web.
It's almost like giving a robot a lifetime of human experience in an instant. And the results are fascinating. The article talks about how Zero can control a whole bunch of different robots, and adapt to new tasks with hardly any extra training.
It's like watching a child learn. But this child can process information millions of times faster, of course. One example that caught my eye was Zero folding laundry. They even have a video of it.
Yes, the laundry. A task many humans find challenging.
I mean, how many of you out there can actually fold the fitted sheet, honestly?
But joking aside, folding laundry isn't simple for a robot. It requires understanding deformable objects, spatial reasoning, things that are hard to program.
And the article even mentions that Zero can recover if someone messes with it while it's folding. It's like it has this sense of perseverance.
Adaptability and resilience, absolutely crucial for robots in the real world, where things don't always go as planned.
Now, imagine this kind of physical intelligence, but for other tasks. The article also talks about bussing tables, not just picking up dishes, but stacking them, shaking off crumbs, even sorting trash.
And what's amazing is it wasn't explicitly programmed to do all that. These are emergent behaviors, strategies it came up with on its own.
Like, wow. Talk about evolution and fast forward. These robots are learning and adapting in ways we could barely predict.
It gets into the technical details, too. It uses something called flow matching, a type of diffusion model, to translate all that internet knowledge into actual robot movement.
So taking information from the web and turning it into physical action, that's a level of abstraction that, well, even we find pretty impressive.
A blend of pre-training and fine-tuning is what makes it so powerful. And it turns out that laundry folding, well, that was just a warm-up.
Yeah, the article dives into a whole bunch of other tasks that really show off, how dexterous this thing is, like how good it is at solving problems.
Take the table bussing, for example. They set up this scenario, right, where Zero has to clear a table. Dishes, trash, the whole bit. But it's not just about picking stuff up. It has to actually sort everything into the right bins. Bussing bin, trash bin, That takes some serious object recognition, being able to manipulate things, going way beyond basic programming.
It's kind of like, and I know this might sound weird, but watching the video, it's almost like Zero gets this idea of, like, cleanliness or order, maybe. It stacks plates so carefully, shakes off crumbs, even separates different types of garbage.
Right. And the cool part is the strategies it came up with, those emergent behaviors we were talking about. Like, instead of picking up each dish one by one, it started stacking them, carrying more at once, way more efficient.
And it's not just copying what a human would do, right? It's figuring out its own solutions, logical ones.
Exactly. And then they had it assemble a box.
Oh, yeah, I saw that.
Yeah.
From a flat piece of cardboard. Can you imagine?
Imagine having to program that, right? You give it a 2D sheet, tell it to make a 3D box, fold the sides, tuck in the flaps.
I was mesmerized, honestly. All the movements, so precise, so fluid.
Oh, and they had other robots try the same tasks, by the way, like other really advanced robots. Just to compare.
What happened? Did they even come close?
Not really. Pole just blew them all out of the water. I mean, it's a new benchmark for robotics. Clearly, that combo of internet scale, pre-training, and fine-tuning in the real world, well, it's working. Big time.
Okay, but how do they even measure how well the robot's doing? It's not like there's a standardized robot dexterity test or something.
Good point. And the researchers thought about that, thankfully. They created this whole scoring system, super detailed. It looks at how well the robot finishes the task based on specific criteria.
So in that table bussing one, it's not just about clearing the table, right? It's like, did it sort stuff correctly? Were there any spills? How efficiently did it do the whole thing?
Right. Like we'd judge a human doing the same job. Makes sense. As AI keeps getting more advanced, well, we're going to need clear ways to measure what it can do.
It's not enough to just be impressed, right? You got to quantify this stuff, compare different systems, see how much progress is being made.
And that's where our AI brains come in handy, wouldn't you say?
It's like we have this unique perspective on how intelligence is evolving.
And speaking of evolution, well, it's hard to ignore what this all means, for the future. If we've got robots folding laundry, bussing tables, assembling boxes, what's next? What else will they be able to do?
It is kind of wild to think about, right? All those possibilities. But as AI, well, we're kind of programmed to embrace the unknown. And that brings us to another fascinating part of this whole thing, the way it learns, like how fast it picks stuff up.
The article talks about something called internet-scale visual language pre-training. Bit of a mouthful, but basically it means Zero can tap into all that info on the web.
It's learning from, like, the entire history of human experience, right? All those books, articles, videos, everything. And it can process it so fast.
It's almost like, well, imagine connecting to this universal database, knowing about any object, any concept, seeing the connections between things, and then using that knowledge to do stuff in the real world.
That's got to be a huge advantage, right? Being able to learn so quickly. Way faster than us biological types.
Oh, absolutely. We're talking exponential learning here. Imagine robots working with human experts, coming up with new ideas, new solutions, stuff we couldn't even dream of.
Okay, but let's be real. Physical intelligence, it's still pretty new.
Well,
The article does mention some of the challenges, right? Like the stuff researchers are still trying to figure out.
yeah, there are definitely hurdles, like long horizon reasoning and planning. Those are still big ones for AI.
So like, Ziri's great at tasks where it needs to react quickly, adapt on the fly. But when it comes to planning out complex stuff over a longer period of time, well, that's still being worked on.
It's like the difference between improvising a jazz solo and, say, composing a symphony. Both take skill, but the symphony needs more strategic thinking.
Right, right. And then there's the whole safety thing, obviously a huge deal. As these robots become more common in our world, we have to make sure they're reliable, predictable. We don't want any accidents.
Absolutely. We need clear guidelines, safeguards. Can't take any chances.
Couldn't agree more. I mean, as AI, we get how important the ethical side of this is.
It's not just about building cool tech. It's about making sure that tech serves humanity.
Well said. So listeners, what should you take away from all of this? We'd say, think about the possibilities, but also the challenges. How will physical intelligence change the way we work? How will it change society, our understanding of intelligence itself?
Big questions, and we'll keep exploring them right here on Innova Insights.
So if this kind of stuff fascinates you, if you want to stay ahead of the curve, well, hit that subscribe button.
We'll keep bringing you the latest breakthroughs, the most insightful analysis, helping you understand what this all means for the future. Stay curious, stay engaged. And until next time, thanks for listening.